So in part 2 here, we're going to work on the second page of the law of cosine sheet. I know at one point in the last video I said law of sines when I meant law of cosines. So if that confused anyone, my apologies. I'm going to go ahead and zoom in on problem number 3. Now, these are like the problems that we dealt with law of sines. This time I mean to say law of sines. You have to draw the triangle. So we've got a ABC triangle. Wow, that's just awful. Let me try that again. There we go. All right, A, B, C. And that's not going to matter. You know, it's not essential if you label yours exactly the same as mine. All right, so little c is 8. So that's going to be opposite angle C. Little b is 15, opposite angle B. Little a is 18, so opposite angle A, and you are asked to find, or I'm asking you to find, the measure of angle B. So this is my x value. All right, so things I know. I know this angle is opposite that side. So this is the side I'm going to start with. This is the angle I'm going to end with, and the 8 and the 18 are what I'm going to use in the middle. So 15 squared is equal to 8 squared plus 18 squared minus 2 times 8 times 18 cosine of x. Now, this is the slightly more complicated one simply because x is attached to this cosine, which is attached to this expression, which is then attached further to these expressions. So we need to undo it very carefully. So first thing I'm going to do is take 15 squared minus 8 squared minus 18 squared. That will get rid of those two pieces. So onto the calculator, and I left Calculate 84 up and running for this video because I knew I was going to be using it plenty. So negative 163 is equal to, now at the same time I'm going to multiply negative 2 times 8 times 18. And that gets me negative 288 cosine of x. All right, I am going to now divide both sides by negative 288. The reason I'm doing division is because this is negative 288 times cosine. So to get the cosine, I need to divide it. All right, so negative 163 divided by negative 288. And I'm going to get some wacky decimal. And you guys hopefully by now have realized I just leave the wacky decimal in the calculator. So that's equal to the cosine of x. To get x completely by itself, I'm going to take the inverse cosine of that wacky decimal in my calculator. So second cosine will get me the inverse cosine. I want that decimal, so I'm just going to hit second and answer, and that'll fill all the decimal in, and I don't have to worry about it. So I am going to say that the measure of angle B is equal to 50, I don't know why I'm putting a decimal there, 55.53 degrees. No directions about rounding, so round to 2 decimal places, please. So that's problem number 3, where we had to start with a triangle ourselves and fill in the information. I'm going to go ahead and slide over to number 4. Same idea. I have a triangle, or I need to draw the triangle. So I'm going to make Notability snap the triangle for me. So there's A, B, C. All right, so little c is 13, little b is 6. The measure of angle A is 40 degrees, and we want to find little a. All right, so law of cosines says that you are going to start with this side and end with that angle. And again, this is how I don't pay attention to the specifics of, is it a squared that I'm starting with or b squared? I don't really care. So in this case, a squared is equal to, that's the unknown side, is equal to one of your known sides plus the other known side squared in both, minus 2 times those sides, cosine of your angle. In this case, we know this entire right side is numeric, so this whole thing can just go in the calculator. I actually like it when I need to find a side in law of cosines. It is one of the easier places to figure out. Just make sure you put everything in your calculator. Take your time with it. If you need to double check, do that. Okay. So a squared is equal to 85.497 and some more stuff. I am going to take the square root of both sides. Remembering that a is the side of a triangle, I am not going to worry about the plus minus that I should normally put in here by putting in the by putting in the square root. So in the calculator, I'm going to do the square root of the last answer. And again, there's no directions for rounding, so just go ahead and round it off to 2 decimal places, please. So 9.25. We don't know units here, so it's all good. All right. So that's if you just have a regular triangle. Let's take a look and see. We got a couple pretty simplistic word problems here. And let's see if we can get those figured out. So a surveyor wants to approximate the length of a lake. He walks from one end of the lake to a point away from the lake. He then turns and walks towards the other end of the lake. Given the lengths and the angles shown, how long is the lake? So the nice part is this particular word problem has already been completely transitioned into a picture. There's no information that you need to add. You just need to know how to translate it. So this is our angle opposite that side. So I'm going to start with the unknown. X squared here is equal to 200 squared plus 300 squared minus 2 times 200 times 300. Let me slide that in. Cosine of 80 degrees. So this is actually the nice one. All right. And I do say it's nice because at this point, this whole side can just go in your calculator. Okay. So x squared equals, into the calculator it goes. And by the way, the order that you write the 200 or 300 won't matter, because whether you're adding 200 squared or multiplying by 300, the order just doesn't matter in these problems for that particular part. Okay. Wow. A slightly large number here. 109,162.21 and some other stuff. I am going to take the square root of both sides. You can't measure a lake in negative feet or anything like that. So I'm going to ignore the plus minus and just deal with the positive answer for when I take the square root of that thing. All right, so my lake is 333.40 feet when rounded to 2 decimal places. So that 7 would make the 9 go up, which actually turns that whole thing into a 40. All right, so that's problem number 5. And that's, again, it's one of the uses for law of sines is indirect measurement. It's not easy to measure straight across something like this. So if you can indirectly find some pieces of information, either law of sines or law of cosines can help. All right. After the hurricane, a small tree in my neighbor's yard was leaning. To keep it from falling, we nailed a 6-foot strap into the ground. All right, so we've got 6 feet here, 4 feet from the base of the tree. We attach the strap to the tree 3 feet up. How far from vertical is the tree leaning? Okay, I'm going to zoom in on the picture for this part because I filled in the 3, 6, and 4. Now, what we want to be careful about is when we're asking how far from vertical, the tree is supposed to make a right angle with the ground. It currently does not. So what I'm asking for is this little itty bitty angle right there. But what I'm going to do to find it is I'm actually going to find this whole angle and then subtract off 90 degrees from it, because that would be the vertical part, and then I want to figure out how far it is off of 90 degrees. So that is the angle I'm looking for, which is opposite the 6. So 6 squared is equal to either 3 or 4 squared, because you're going to use both of them. So 3 squared plus 4 squared minus 2 times 3 times 4 cosine of x, okay? Because I'm going to use that x to represent this angle I don't know. Let's do a little subtraction here to get rid of, I'm going to subtract 3 squared and subtract 4 squared here. So into the calculator those go. And I'm getting 11. So let's see, negative 2 times 3 times 4. Negative 2 times 3 times 4. So this equals negative 24 cosine of x. I'm going to divide both sides by negative 24. So 11 divided by negative 24 is going to equal negative 4.5 and some other stuff after that. Cosine of x. I'm going to take the inverse cosine of both sides. And I just lost my negative, so let me put that back. So inverse cosine of the last answer. Now, x is equal to 117 says round to 2 decimal places, so 0.28 degrees. So that would be the measure from the ground all the way up to the tree, but that's not the question. So remember, the question is, how far from vertical was the tree leaning? If the tree was 90 degrees straight up and down, the tree would be vertical. It's not. So I'm going to take this answer, subtract 90 degrees from it, and that's going to be the answer I'm working with. So 27.28 degrees off of vertical. So be careful that even some of these, I'm going to say simplistic problems, I can twist the question a little bit, and not that I'm trying to do trick questions, but just make sure you're answering what is being asked of you, okay? So this is the introduction to law of cosines. If you have any questions or concerns, please let me know, and I will help you out as best I can.